Welcome to Star Chat, the podcast that explores the wonders of the universe and brings you the latest news from the world of astronomy. I'm your host, Carl, and I'm thrilled to have you join me on this journey through the cosmos. As we begin today's show, let's take a moment to appreciate the vast expanse of space that surrounds us. With billions of galaxies, each containing billions of stars, the universe is full of mysteries waiting to be unraveled. And one of the most fascinating areas of study is the formation of planetary systems. Imagine being able to witness the dawn of a solar system, with planets coalescing from disks of gas and dust surrounding young stars. It's a process that has captivated astronomers for centuries, and recent discoveries have shed new light on this complex phenomenon. One such discovery was made by a team of researchers who used the Very Large Telescope in Chile to study a binary star system located 440 light-years away. The system, known as HD 135,344 AB, consists of two stars separated by a vast distance of approximately 2,800 astronomical units. That's about 260 billion miles, or 420 billion kilometers. What makes this system particularly interesting is that one of the stars, HD 135,344A, has already formed a planet, while the other star, HD 135,344b, still has its original protoplanetary disk intact. This unique configuration allows astronomers to study the formation of planetary systems in unprecedented detail. The discovered planet, dubbed HD 135,344 AB, is a young, massive gas giant, orbiting its star at a distance similar to that of our own solar system. The team used advanced instruments, including the sphere and gravity instruments on the Very Large Telescope, to confirm the planet's existence and determine its properties. This finding has significant implications for our understanding of planetary formation in binary star systems. It suggests that the process can occur at different rates for each star, even when they are separated by vast distances. The researchers believe that this discovery could provide valuable insights into the formation of our own solar system and the potential for life to exist elsewhere in the universe. As we continue to explore the wonders of the cosmos, we're reminded that there's still so much to learn about the universe and its many secrets. From the formation of planetary systems to the search for life beyond Earth, the journey is full of exciting discoveries and new frontiers to explore. We'll be right back with more fascinating space news on Star Chat. Welcome back to Star Chat, folks. I'm your host, Carl, and we're diving into the fascinating world of space exploration and policy. As we navigate the vast expanse of our universe, it's essential to stay informed about the latest developments in space technology, funding, and innovations. Today, we're focusing on a story that highlights the intricate dance between government agencies, private companies, and technological advancements in the space industry. The recent House budget bill has passed a key subcommittee vote, and it includes some interesting provisions for NASA's Space Launch System program. Specifically, the bill allocates $2.5 billion for SLS, close to this year's funding level, and $500 million more than the Trump administration's request. Now, you might be wondering what this means for the future of space exploration. Well, the House budget bill also includes a paragraph that directs NASA to study alternatives to the current exploration upper stage design. This is where things get interesting. The U.S. is a critical component of the SLS Block 1B upgrade, which aims to increase the rocket's lift capability and enable it to carry co-manifested payloads, such as an Orion crew capsule and equipment for NASA's Gateway Lunar Space Station. However, with the Trump administration proposing to cancel the Gateway program, it's unclear whether the U.S. will still be needed. Enter private companies like United Launch Alliance and Blue Origin, which have developed their own upper stages that could potentially be used on SLS missions. ULA's Centaur V upper stage, for example, is sized for their new Vulcan rocket, and has more capability than the interim upper stage currently used on SLS. As we explore the possibilities of using alternative upper stages, it's essential to consider the implications for NASA's budget and the future of space exploration. The Senate Appropriations Bill also directs NASA to continue ordering spares and long lead parts for SLS and Orion missions beyond Artemis III, indicating a commitment to these programs, despite the uncertainty surrounding their funding. As we navigate this complex landscape, it's clear that the next few months will be crucial in determining the fate of NASA's SLS program and the future of space exploration. Will Congress find a way to compromise on the budget, or will we see significant changes to the agency's plans? The world is watching, and we'll continue to bring you updates and analysis here on Star Chat. Stay tuned for our final story of the day, right here on Star Chat. Welcome back to Star Chat, folks. As we wrap up another episode of exploring the wonders of our universe, I'd like to take you on a fascinating journey to the very heart of our planet's rhythm. You see, Earth's spin is not just a constant. It's a dynamic dance that affects everything from our clocks to our calendars. And recently, scientists have noticed something remarkable. Our planet's rotation has been speeding up, which could potentially lead to a phenomenon known as a negative leap second. Imagine, if you will, a clock ticking away at an ever so slightly faster pace than it did just yesterday. This might not seem like much, but the implications are profound. You see, our modern world relies on precision timekeeping, from GPS navigation to financial transactions. And if Earth's rotation continues to accelerate, we might need to introduce a negative leap second to keep our clocks in sync with the planet's spin. Now, I know what you're thinking. What exactly is a leap second? Well, my curious listeners, it's a 1-second adjustment made to our clocks to account for the Earth's slightly irregular rotation. Usually, we add a positive leap second to keep our clocks aligned with the planet's rotation. But if Earth's spin continues to speed up, we might need to subtract a second instead. Hence, the term negative leap second. The possibility of a negative leap second has sparked a lively debate among scientists, with some predicting it could happen as early as 2029. Others argue that our planet's rotation will slow down again, negating the need for such an adjustment. As we wait to see how this unfolds, one thing is certain. The intricate dance between Earth's spin and our human endeavors is a reminder of the awe-inspiring complexity of our universe. As we gaze up at the stars, let us not forget that our planet is part of a vast cosmic tapestry, with rhythms and patterns waiting to be unraveled. And who knows? Perhaps one day we'll discover that Earth's rotation holds secrets to the universe's own harmonies. That's all for today's Star Chat. Remember to like, share, and subscribe. And until next time, remember to keep looking up at the stars.